Hello everybody, welcome. This video is meant to explain how to calculate the standard deviation of a set of data. We're going to use a very small set of data. I'm going to go ahead and write a few numbers that are going to be very easy for me to use. If you are not familiar with the standard deviation, it is basically a measurement of the average distance from the mean that you have. And we do use a formula to solve it, although the formula that you use could vary depending on your professor, for example. I will use a very specific one, but there is an equivalent, if you will, if you are looking at something that looks different. But as the name implies, the standard deviation does require that you know the mean first. So really the first thing I need to do is find the mean of my numbers that I have here. So what I'm going to do is I'm going to write down the mean formula, which is x bar is equal to the summation of the addition of the individual values divided by n, which represents your sample size. So it is very important to know these formulas for the sake of being able to solve statistics formulas. So like I said, this is the symbol for the sample mean. This is the symbol for a sample size. This is the symbol for meaning individual values. It could just be a regular x. It's not necessarily anything other than an xi or an x. And this symbol here simply means sum or add up all those values. So we are adding our individual values and then dividing them by our sample size. So in this situation, we're adding 21 plus 19 plus 17 plus 23 to get 80. That's the summation. That's the top part up here. And we're going to divide it by our sample size. There are 4 values, therefore our n is 4. So we're going to divide our 80 by 4 to get our sample size. Our sample mean of 20. So our x bar for this set of data, this 4 points of data, is 20. So 20 is the x bar, and it is going to be relevant for finding our standard deviation. So as I mentioned, we are going to need our formula. We're going to use S to represent sample standard deviation. And there is a difference between a sample standard deviation and a population standard deviation, but it's a very small one. It does make a difference in the final number, but I'll just mention it later when we get to it. So I'm going to go ahead and write our formula for finding our standard deviation. And like I said, it does require that you know what the mean of your data is. So if you do not have it, you're going to need to calculate that first. All right, so here it is. It is the square root of the summation of your individual values minus your sample mean squared. You're going to add that after you figure this part out and then divide by n minus 1. That's if you have a sample. If you have a population, do not subtract the 1. A population standard deviation would just have divided by n, and it uses the symbols that correspond to it. For now, we're just going to stick with all the symbols for a sample, and you can tell from the breakdown this is the sample standard deviation, right? And you should be familiar with the rest of the symbols as we've seen them already before. So our first step is really, if we're following the order of operations, to do everything in our parentheses. And in my parentheses, I have the individual values we are going to subtract the mean from them. So we're going to take each of our values here. That's what the xi means. We're going to take each of the values here, and I'm going to make a chart to kind of help me organize this a little bit better. We're going to go ahead and write each of the values: 21, 19, 23, and 17. And we're going to go ahead and subtract from each of them the sample mean. Okay, so we're going to go ahead and take 21 and subtract our mean, which is 20, 19 and subtract our mean, which is 20, 23 and subtract our mean, which is 20, and 17 subtract our mean, which is 20. We do all of that correctly, we're going to get our answers, which are going to be 21 minus 20 is 1. 19 minus 20 is -1, 23 minus 20 is 3, and 17 minus 20 is -3. So our answers for this column are these values right here. That's just our x individual minus the x bar. That's the first part. Next, we're going to do exponents according to our order of operations. So that means we're going to go ahead and square each of these answers here on this column. So I'm going to go ahead and write the symbols for what we've already completed, and then include the squaring of that situation. So each of these numbers squared, 1 squared is just 1, -1 squared will become a +1, 3 squared is 9, and -3 squared is also +9. So we have here our individual values minus the mean and then squared. These are our answers for that specific step. So we completed so far this up here. Next, we need to do the summation. And in order to do the summation, it's pretty simple. We're just going to go ahead and add the column. This is pretty standard, 9 plus 1 plus 1 plus 9, which is going to be 20. So my step here, my summation of the x individuals minus x bar squared is equal to 20. Next, we're going to go ahead and divide by n minus 1. N, just like before, is the same number still, 4. So we're going to go ahead and take 20 and divide it by 4 minus 1, which is really 3. So it's 20 divided by 3. That one's one that I'm going to do in my calculator really quick. 20 divided by 3. It's 6.66 repeating. So we're going to go ahead and say that our our standard deviation is going to be equal to the square root of whatever 6.667 repeating is. And so if I do that really quickly on my calculator, we'll see that our standard deviation for this data is 2.58. Okay, that is if you're solving it by hand. This set of data is very small and easy to work with, so I'm able to actually do it by hand. Your professor may give you more numbers to work with, which means you would have a longer list of numbers to calculate over here. If, however, you are allowed to use a calculator, you definitely want to make sure that you learn how to do it. And it is possible to use the calculator to make these calculations very fast. So if you're using a TI84, when you turn it on, in order to do this problem a little quicker, you can do stat and edit and then enter your values. So I have 21, 19, 17, and 23. There are 2 ways to do this. I can do this step by step. Some professors will allow you to do it all at once. Some professors will have you do each individual spot. I'm going to go ahead and do each individual spot, and then last in the video, I'm going to show you how to do it all at once. So first, I have the numbers in my L1. I want to do our first step, which is subtract the mean. So I can tell the calculator to, if I put second and the number 1, it will take the L1 symbol and then subtract 20 from each of them. So it's going to take each number in L1 and subtract 20, giving me my answers. And as you can see, they will match up with my numbers in this column. And then if I want to continue, I can go up to L3. Remember, you need to go up to these labels up here and tell it to do L2 and square the values that are in L2. Right? So caret with the number 2 will square each of these values and then give me the answers. If you have a longer list of data, obviously this is very helpful. You're going to have all of these numbers available to you. As you can see, we have 1, 1, 9, and 9 from our data. I can add them up and then do our final step like I did earlier, straight up on my calculator to get my answers, right? Now, if you just want to do it all at once and check your answer, you can also press the stat button. Once you've entered your data, you can go over to calculate, which is the top tab up here, calculate. Tell it you want one variable statistics, and then all you got to do is tell it where your data is in list 1. We're not in frequencies in this point in time, so all we need to do is have L1. If there's something here with you just want to have one list of data, you can just leave that blank and be okay. So I go ahead and calculate. You'll see that my standard deviation S is also 2.58, just like I got myself. And that is how you calculate a standard deviation very easily with a small set of data. Thank you for watching. If you need any other advice or situations for statistics, please let me know in the comments. Hopefully it's been helpful. All right. Have a good one.